Good morning, everybody. Welcome to our first series of the webinar scripting series. I'm glad you could join us today. We're excited to share this content with you in a format that's designed to be both informative and interactive. We'll start the presentation followed by a live Q&A segment. During Q&A, we'll highlight a few selected questions to discuss as examples. Don't worry, every question submitted will be answered directly, either during the session or afterwards. We encourage you to ask questions throughout the video using the chat or Q&A feature. Your input helps us make these webinars more valuable for everybody. Cyclone 3DR is a powerful software and we want you to make the most of your license. So for now, let me introduce you to, let Jennifer introduce us to the first session. I'll hand it over to Jen.
Thank you, Joel. Hello, everyone. Thank you for joining us today. We've been seeing a growing demand in terms of scripting for 3DR, so that's why we thought we could organize some tutorials and empower more users to get into scripting. This webinar series is really for beginners, so it's typically for 3DR users who have no scripting, no programming experience and don't really know where to get started and how to get started. We will have different themes for each webinar. The first two are going to be part 1 and part 2 of the same script. We're taking things slowly. So I will show you how to write a script from scratch and take you through all the steps in detail. And some of you can potentially even follow as we go. The theme for today is to run a classification on a point cloud, so very handy function. Let's get into it. Let's write a script together in Cyclone 3DR. There are a few steps that are always important to follow when writing a script in Cyclone 3DR. First one, it's always recommended to get some sample data ready. It will be easier to test the script while writing it on a small portion of data rather than on the full project. So let's get this going. Get our sample data ready. So I have prepared a file already, imported a point cloud inside Cyclone 3DR. This is the data I'd like to work on today. Small portion of a bigger point cloud. Now, next step, write a description of the script. Always better to write a clear description of what the script is going to achieve so we know exactly where we're going. For this, we're going to open directly our text editor. I'm using Notepad++ to start writing the script, and I will add the description of the script straight at the top. Here we go. This script will classify a point cloud and extract only one classes out of it. I will explain on this data here. What I would like to automate is to run a classification on it and extract only the class that contains the pipes so that I can very easily go into the pipe modeling tools that are in 3DR. This could be an action that I'm doing very regularly if I am modeling pipes very regularly, so running a classification and extracting only the one class out of it is an action that I would like to automate and be able to play just with a click of a button. Now, before I continue to write anything in this script, I will save it as a JavaScript file. So in here, we'll scroll down and say JavaScript, and I will give it a name. I will call it pipe classification. Okay, and now we'll have access to all the tools of JavaScript language, which the first one to know is those two slashes are to declare that a comment will be written afterwards. Now I can write more details about the script. For example, at the moment I've got the point cloud included in the 3DR project already. So I'm gonna simply ask the user to click on that cloud. There's different ways to do that. What I'm going to do to keep it very simple here is that I'm gonna have the user selecting the cloud before launching the script. This is important to know, so I will write it at the top of my script as well. The user select the cloud before launching the script. That's it. So don't hesitate to describe more in detail, but give as many detail as possible, really. Now, what's the next step? Play the steps in 3DR. So very important before starting to write anything in the script, really, make sure that what you're going to write is actually doable in 3DR. So validate all the steps in 3DR to make sure it all works as you expect, and then you'll be able to write those steps. So let's do that. In 3DR, what I would like to achieve is here, run the auto classification. So I'm selecting my cloud, going into here. The model that I need to use to extract the pipes will be this one, indoor construction site 1.3. You'll see here if I scroll down, this is the one that corresponds the best to my data set right here. So, and I'll have the pipe class. So I'll do a preview of that. This gives me an idea of how long the computation can last as well, which will be the same duration within the script. Here we go, the classification has been done. I'm going to say OK to that. And now we've got still just a 1-point cloud that has been classified. What I would like to do now is separate by attributes. So I'm going to click on this one. I want to separate according to the classification, so I'll say OK to that. And now I'm having all of these point clouds. The only one I'm interested in is the pipe one. So I could either delete those or just hide them. I'm going to delete them. And this is what I would like from my script. So I'd like to come from the original point cloud and achieve this. So this is an easy one. There should be no issue scripting this to obtain the same result. So we've validated our third point here. Now I can go into writing the script, writing the detailed step-by-step for the script. What I mean by that is that here, now that I've played it in 3DR, I know exactly what are the steps that the script needs to go through. First step, we'll need to check that the user has selected a point cloud before launching the script. Then we'll be running the classification on the selected cloud. Once the classification has been done, we want to explode the cloud according to the classification. And we want to only keep the class that contains the pipes. That's it. So only a few steps here, but we've got our outline. And now we can start scripting. So we'll just go from the start one step at a time. And what will be important is to validate each step before moving to the next one. So as soon as I've written something, I can start launching it in 3DR and flick back and forth between writing the script and starting it in 3DR to test it continuously. So the first step is to get the cloud that the user has selected before launching the script. How do we do that? Best is to check within 3DR. We're going to go to the help file. And here, the help for the programming is in here for the scripting, help for JavaScript programming. And you need to jump into here to find the functions to use, documentation of script API. Now, when you know your way a little bit, you can jump straight to the classes, class lists. The object we're after getting is a point cloud. So the class that's relevant to that is an S-cloud. I can click on that class and I will see all the different functions. The way I like to try to find a function is to actually open this little arrow and then scroll down, and you can read all the functions that are available to be played on an S-cloud. Now, if I come down, you will see here those functions from are to grab an object. You will find the same ones for all different types of objects, whether it's a mesh, a cloud, a model, etc. What we are going to do now is that our point cloud will be selected before we start. So it is this function that we need to use from cell. So we need to use sCloud from selection. So that's what we can do here. It will be sCloud dot from cell. Now you can look at how it's written, and you see there is a return value. The return value is an array of clouds because there could be more than one selected cloud. Okay, and it does say here get all the selected S cloud. A good best practice is to copy the description here and add it as a comment right there. That way you know exactly what this line is doing. So what I need to do is declare a variable that is the result of the selection. So I like to write it res select. Result of the selection is this, and this will be an array of clouds. Now, when we get a selection like that, there are a few things that are always good to do. Again, a best practice. Let's check that something has been selected, because if it hasn't been, we won't be able to follow with the script anyway. How do we do that? What we can do is check that if this value is not equals to 1, which means if this array is either smaller than 1, which means 0, nothing has been selected, or bigger than 1, multiple clouds have been selected, we'll throw an error to the user and tell him, sorry, you have to select only one point cloud before starting the script. So we can do that. So if our result here, our table, so to check the length of a table, very easy, you just say dot length. And if you want to say something is different than a value, it's exclamation mark equal 1. This line here means if the result of the selection, if the array is different from 1, then action something, because we can't run the rest of the script. Something that's very handy is this one, throw new error. And now this line means that it will stop the script and come out of it. This prevents from starting a script on something it is not planned to be played on. Now we can be a little bit nicer to the user, and in here we can actually include a message so that the user who clicked on the script gets a bit of feedback as to why the script stopped. So let's say select one cloud before starting the script. Here we go. So this is how you write a message in there. And basically, if this happened, then this is here, which means that if we get to the next page, it means our selection is only one cloud, then we can get that cloud. So what I'm going to do now is grab this cloud that has been selected. So always declare your variables like that. And I tend to call it my cloud. That's the one I'm going to be working on. You could call it my selected cloud to be more precise. It's really up to you, the naming. So how do I grab the cloud? I grab it from the resulting list. And how do you access an element in a list? With this tool. And it's the element number 0 that we want to get. And we can confidently get this element because we know that there is only one element in this list that has been returned from the selection. So get the selected cloud in the list. This is what this does. Here we go. We've got our first step done. So what you can do as well is that I like doing this to define the main steps, and we're ready to run the classification on it. So I'll do the same. I'll just do that. And now I can save it. So there's not much to really test in 3DR at the moment, but we can still do it just to see how that works. So coming back to 3DR, I'm just going to do a Control Z on what has been done so that I'm back to my original cloud. Here we go. So that's my original cloud. There's no classification computed on it yet. How do we launch the script in 3DR? You just go to the script menu, run script, and here, so you could actually be writing a script in there directly. Much easier to use a separate text editor. So here I need to come and load the script. I'll choose it from here, open. By default, you will see the script here. So I can just start it like that. I will click. And now, because I started it, I didn't select anything before clicking on start. And we can see here what's happening. We are having our error, and the script has stopped, and our error is saying select the cloud before starting. Now, if I select the cloud and then I start the script is done. Obviously, it's not doing anything, but I'm not having the error being thrown. Let's go back. Now, let's run the classification on the selected cloud. So to do that, we have to know which function is actually the one to use to run the classification. So let's go into here, and you can either try to find it here, or you can try to go by the research, and you can see here the search bar, sorry, you've got classify as cloud. So that's most probably it. If I click on it now, you can see here, classify the point clouds using a trained model. And here, what we have to read, this is the declaration of the function. In the parenthesis is what the function needs as an input, and then this is what's going to come out as an output. So you see the detail here. As input, we need a list of clouds that we want to classify, and we need the name of the classification model to use on it. And then as a return, and this is very often the case, you will have a return value that has an error code that could give you a bit more information about what might have happened if it failed. And then you have the returned elements. So here, what we will get is a table of clouds. So same as when we did the selection, an array of S clouds. So it's a table of the classified clouds. It is a table because you might bring a table as an entrance. So you could classify more than one clouds at once, which means you would have more than one result. We're keeping it simple here. We're using just one cloud, so we will have just one as a result. So this is the function to use. So you can potentially copy that and paste it here. As always, I know I'll have a return value, so I'll do result from the classify will be scloud.classify. And here I'll just adapt it a little bit. What you can do, which is sometimes a good practice, is to write it this way, and then you can add the comments from here. So our first thing is the table of clouds to classify. So I can add this as a comment here, and then the model name, like this. So the table of cloud to classify, it's easy. It's the table of cloud we selected. So I can just copy that, put that in here. And then the model name, I have to write that somewhere. So remember when we tested the script in 3DR, we could see which was the model name that we need. So if you're not sure, you can always come back into it. And so this is what we need, indoor construction site 1.3. So here, you can write this just in here, indoor construction site 1.3. You can write it like that, Or something that is interesting in most scripts is that you could have this as a variable and have it at the top, which means that if you run a different model, you would just have to change at the top. I'll show you how that works. If I declare it as a variable at the start and I say model name, for example, equals, and I'll put that here, and I can say the name of the classification model to run. And here, instead of writing it like this, I use model name. Let's save it. Now, what we need to do is the same as here. We run a function and then we check the result before we access the result. So same thing, we're running a function. So now we need to check the results. And we could see that there are a number of results that can be returned. So the error code or this. One way of doing this is to throw an error to the user with each single message so that the user has more information about what happened. So here I can treat each single one. So if the result of the classification, if the error code is 1, if the error code is 1, an error occurred. So what we do is much easier just to copy and paste once you have a start. And I can just say here, I can copy the message from here. So when you're scripting, there is a lot of copy paste happening. Now, I want to check also if we're getting 2 or 3. So what I can write is else if. So if it's not 1, but it's 2, I can copy that equals 2. Then I also want to stop the script, but I do want to have the message. I'm just making more space with there. The second message, an error occurred with the inputs. So let's put this. And then last one, else if it's equal to 3, the model does not exist. So the model does not exist. That means that we probably asking it to run a model that's not valid. So that means there might be a typo in the name that you're trying to play. And this done this way means we're checking every single error and we will stop the script each time. So if it went through all of those tests, it means there was no problem and the return value has to be 0. So again, there's different ways of doing that. I'm just showing you one possibility. So if it went through all that, it means we are able to get our point cloud. Now, the point cloud is not given as is, it's a table. So what we need to do is still check that this table actually has a result included in. So we'll do pretty much the same as up here, where we'll do the return cloud table, the length of it. If the length is 0, then we will also throw an error. And here I can say, for example, no cloud classified. It failed somehow. So, and if the return table is anything else than 0, it means we have a result. Something has been classified. So we can go to the next step, and I can grab now the resulting cloud. So I'll do that. I'll call it my classified cloud. So we'll grab it in the cloud table and we'll grab the first element of it. So we're not here checking that it hasn't returned multiple elements. We'll just keep it a bit simple. Get the classified cloud. Here we go. So now let's run the script to see if this works. So what you will see, just one more thing, I'll save here, is that here I've just opened the file. This is not linked at the moment with what I'm writing here. So what I need to do here, and I think that's always a easier way to be scripting, is to actually use this option, use an external file. If you click on this option, now you don't see the script here, but it reads this file that I'm writing. So you have to always make sure you save so that 3DR will take into account the changes that you've made. Now, if I start it again, I will select the cloud and start the script. And here you see which function is currently being played. The script is done, so it tells you it was 30 seconds. We can't see anything though. So when you're checking your script, you actually have to add more lines while you're writing it, just to make sure that what you're computing is actually correct. So I'll show you how we do that. Ideally here, we would like to see the classified cloud just to make sure it has run correctly. So what I can do here, and I'll show you how to do that. How do we add this cloud into the document? There's one function for that. My classified cloud dot add to doc. This is the function to use to add the cloud in the 3DR document. So you find this add to doc, I'll just search for it, in not in a specific object class, but you can see here it's scomp. So comp means component basically. If I just click at the top there, components means all of the objects pretty much. So all of the objects have some functions that they have in common, all of them, and those functions that are in common are under this class, scomp. And you can see here a little bit the functionality. So you'd have add to a document, or a selection as well can be done, get the bounding box, the colors. There's a few things that are just common to all of the objects inside 3DR. Here we go. Now we've added that, so I'll save and we'll run the script again. So I select it and run the script. And this is why you want to run it on a sample of data, because potentially the functions that you're using within the script might be taking a little bit of time. Here. So now I can see another cloud has been added into it, and you can see this is my cloud. So what I kind of need to do here to see whether it has been classified is that I need to hide the original cloud, and here I also need to change the representation to classification. And now I can see that this has been classified. So success, our script is working. Now to have a debug mode that works well, what I've just done, hiding this and changing the representation, is something we can do in script as well, and would be nicer so that we don't have to do it manually. So if I go in here, remember we grabbed our um, cloud here. We can simply, that's the original cloud that got selected. I can simply make it, hide it. So what we do here is my cloud, and the function to use is set visibility, and we'll say false to say not visible. So I'll say hide the original cloud. So that will do that. And then the classified point cloud, by default, it's just represented in smooth because that's the default view for point clouds in 3DR. So now we need to change it to the classification. Where do we find that? It's, we'll have to go to the S cloud again for that one. And here we should have an option that does set cloud representation. And you can see here the different options for a point cloud. So this representation is specific to um, the cloud itself, but that's the function to use. So it's set cloud plus the option that we're going to choose, and we'll choose this one, cloud classification. So what I'll do, I'll just put it straight under that, classified cloud dot set representation, and here I need to put this one as cloud classification. Change the presentation mode to classification. Here we go. So let's save that and see if our script is working. So what I need to do here, because the script has actually done something, is I need to do a Control Z, a couple of them, to come back to the original stage of my data. So again, selecting the data, launching the script. And now we have an error. So if you made a mistake in your script, you will get information here about it. So it's saying line 39, we've got an issue. My classified cloud is not defined. So I must have done a typo. Line 39. Yes, I forgot the L there. So that's it. That's why it's good to do copy paste. So that's how it goes to write a script. You get your information there, you correct it, you save, and then start again. So I'll do a Control Z and then select it, run again. Yay! So perfect. Our original cloud is hidden and the new one is here and it's in classification mode. So perfect. I'm having just a little message here. This function is deprecated and I have to use another one. So we'll leave that like this for now because it's not creating an issue now in our script. But first step of the script is now done. We have been able to well, select the point cloud, run a classification on it, and output the classified cloud. The next step will be to exploit the cloud according to its classification. And we'll do that in the following video.
Thanks, Jen.
Here we go. That's where we stop with our first video here. We will see the next part of this script in the next webinar that will be done next week, pretty much at the same time on the Wednesday. Thank you for following up so far.
If anyone has any questions, please feel free to put them into the chat. We've got a couple that have come through so far. Jen, where can I find scripts others have created? Is there a website I can visit?
Yes, that's a good question. So there is actually a platform called GitHub. This is mainly where scripts would be shared for 3DR. 3DR themselves have created the platform, and they share scripts that they might have written themselves for customers and for support as well. So it's called GitHub. And if you look for 3DR GitHub, you will find a link to that. There is a link to it through the help of 3DR as well.
Is it possible to edit the built-in scripts within 3DR? For example, the curb script.
Yes, that's a good question. So you can see that in the script menu itself, there are some that are favorites by default in there. These are scripts that have been written by the 3DR team itself. And so the curb extraction is a good example of that one. So when you play them, you can actually see the script in the little dialog box on the right side of the screen. So you can easily modify it in there, or you can also save that file and then modify it yourself. There's one that I modify regularly. It's the electric line extraction, for example, because the way it is at the moment, you need to launch it each time you want to extract the next electric line. And if you just make it run in a loop, then you can just go and keep clicking seed points and it keeps extracting. So you can definitely take those scripts and modify them yourself. Yes.
Can I have a copy of this webinar? Where can I get your example script from?
Yes, so every attendee will receive a link to the recording of this webinar shortly after we close this session in the coming days. We are in the process of uploading the scripts that you will see in these series to the GitHub platform from 3DR. The first one is not up yet, but that will be done shortly as well. So we will share that with all the attendees as well.
Is a specific license needed for scripting?
That's a good question. We get that question quite regularly. There is no specific license needed to be scripting. So the script menu and the scripting capabilities themselves are included in the standard version of 3DR. So there's no special license needed to start scripting and launch a script. The only thing you have to remember is that 3DR does have different options, so like the survey package or the plant package, etc. So some of the functions in the scripting will be protected by those. So for example, the classification that I played today, the classification is actually not included in the standard version of 3DR. You need one of the options like the survey or the AEC edition.
Got a good question from Ronan. Would you recommend any AI to write scripts?
So I don't have a recommendation like that. We have seen through support, we've seen different attempt at using an AI to write scripts. So I think some of them do better than others. the best thing if you're trying to use AI is to make sure that AI is using the help files, obviously from 3DR, to be writing the script. What we've seen so far is that a lot of those attempts, the script that comes out of those AI would be actually inventing functions that are not within the 3DR help, and that has happened quite regularly. So I haven't seen a particular AI that has been fully successful. Now I'm happy to get all of your comments if some of you have managed to use it well, because that would be great for us to know as well. So I think it's still quite important to know how to be scripting, or at least to know how to, because you need to know how to debug a script. Basically, the AI will generate something for you, but if it doesn't work, you still have to go into it and read it and see, oh, okay, that's not a function that actually exists in 3DR. Which one is the one I should be using? So I've got no doubt in the future there will be more and more capabilities, and we'll see better results in that area. But at the moment, you probably still need to know a bit more yourself to use it successfully.
Yeah, there's, like you said, there's been a lot of people trying to use it, and it really hasn't been successful. It seems to really struggle, doesn't it?
Mm.
Jacob, um, are all scripts limited to selecting from inbuilt functions and settings? In other words, can scripts enable novel functions, i.e. train roll section of best fitting using a supplied polyline selection?
So the whole idea about scripting, there's two main goals when you write a script in 3DR. One of the goal would be potentially to automate a process. So that's a bit more what was the application today. The idea was that I do a series of, I have a workflow that I do very regularly. I'd like to be able to kind of just click on a button and get it done. I can do that through the scripting. So automate one workflow. The second goal of scripting is also potentially to write your own ideas. So write your own algorithms. And so extracting anything, the main thing is to have a good ID. So if there's something you're kind of able to do manually, sort of in 3DR, but then you need it to upscale it to be done at a higher rate, or on a full point cloud, etc. That's the sort of things that the script will enable to do. So typically rail extraction is something you could write in the script. Scripting will be a bit limited compared to what you do in the program itself to a certain extent, but you can do a lot through that. So definitely, yes, you can write your own algorithms by combining all the functions that are available in 3DR. In 3DR, for those of you who are very good users of 3DR, you will know that 3DR has those like elementary functions like projections, copying, translations, moving objects, using a matrix, etc. So all the key, more mechanical sort of functionalities.
And it might be a similar question from Freddie. What other scripting options does Cyclone 3DR support for automating? So I think it's a similar question. I think Freddie's asking, what other options can you automate potentially? So there's there's
Yeah.
features within 3DR that basic features like Jem was saying, you can automate from A to B or A to Z depending on your general workflow. But you can also be quite advanced with your scripts and come up with your own equations for solving things as well.
Yes, exactly. So you can also choose to what level you'd like to automate. So what I'm showing in what I showed today in the script is not too automated, because I'm asking the user to actually select something manually and then run it. It is possible to actually run a script inside 3DR through command line. So without even opening the 3DR software at all. That's possible as well. So that will not be a topic in this beginners series, but it is described in the help from 3DR how to do that as well. And so ideally, if you just launch a script through the command lines, what you can do is having your script automatically loading data, running all the process and exporting into a specific spot on your computer. And without even opening 3DR, you've got an entire workflow that has been done, and all that through scripting.
It's good timing, because Kieran also mentioned that in the chat. In response to 2 questions of automating, 3DR scripts can be ran without opening 3DR as well. So it's possible,
That's right.
but it's limited, yeah. Now I think that wraps up all of the questions actually, Jen. So just a quick reminder to everybody, we've got 4 videos. Can we use the MCP, Model Context Protocol?
I don't know. That is a good question.
Yeah.
We will have to look into that one. So all the questions we might not have answered at the moment, we will contact you per email and come back to you.
Yeah, we'll let you know, Freddie. So that was part 1 of a 2-part series. The next webinar is next week, okay, on the 26th, same time, same place. And then we basically have 2 more webinars to close out the year, which start to get a little bit more advanced. But look, it's worth coming to all of these. It's worth pulling out Notepad++ and typing along if that's your learning style. You can get Notepad++ straight from the internet. Just you can Google it and download it direct from their website. It's pretty much the most common tool to use, like Jen explained. But yeah, same time next week, we will catch you guys for part 2 of pipe classification in Cyclone 3DR. Thanks very much, Jen, for running this, and thank you to everybody who's asked questions and everyone that's attended the webinar. Thank you, guys.
Thank you.